Okay, welcome back everybody. Today we're working on more solving practice. The first thing we're looking at is the warm-up problems. And the 4 problems we have today, I just have them in different colors for us. The first one, 2 sine of x plus 1 equals 0. The very first step you're going to want to do on that problem is you're going to want to solve for sine of x. So get sine of x by itself. So we get sine of x equals negative 1/2. The next thing you're going to want to do with that is you're going to want to look at your unit circle down below. Everywhere where the sine value equals negative 1/2. What we should remember from last time is if we look at the unit circle below, we can draw a triangle, and I'm going to draw a yellow line here to represent straight up where there's a negative 1/2 value for the y value. And we have to think about, hey, there's an angle theta always being formed with the x-axis, and that y value is our sine function. So sine happens to be negative 1/2 at 7 pi over 6, and then there's another negative 1/2 at 11 pi over 6. So that's how we would end up with our 2 answers for x, our 2 possible values. Similarly, with the green problem, we see sine of x equals root 3 over 2 once we solve for it. So we look for the y values that are positive root 3 over 2. There happens to be one at pi over 3. There happens to be another one at 2 pi over 3. That's how we end up with the answers for these types of problems. Alright, hopefully that gets us started with the warm-up today. I'm going to go ahead and erase the unit circle now and just clear it up for our practice problems below, so we can get some more practice today. One important thing to note about the warm-up as well is that all of the problems today we asked to go from the interval 0 to 2 pi. Alright, we're going to ask that same exact interval, alright, down below. And 0 to 2 pi is typically 1 revolution all the way around the circle. So we're going to look for all the values 1 time through the circle. Okay, that could change from 0 to pi. It could be negative 2 pi to 2 pi. Changes from problem to problem. Starting with our first example today, example A here, we've got the sine of x minus pi over 6. And we can really just kind of think about it as just sine of x for now. What we want to do first is we want to get everything else to the other side of the equation. So our first step is going to be to subtract 1 from both sides. So we get 2 sine of x minus 6 equals negative 1. Second step, divide both sides by 2. And we have this x minus pi over 6 equals negative 1/2. And now we want to go to our unit circle and we're going to ask, okay, when is the sine function negative 1/2 on the interval from 0 to 2 pi that we have listed up here? So I look at the y values. I see a positive 1/2. Nope, another positive 1/2. I see a negative 1/2, so 7 pi over 6 is one of our possible answers. And I see another one at 11 pi over 6. So that's what I want to write down then. X minus pi over 6 is equal to 7 pi over 6. Another possible answer, x minus pi over 6 equals 11 pi over 6. So just like what we did last time, except now we're dealing with this shift of minus pi over 6 that we're going to have to make an adjustment with here. So if I add pi over 6 to both sides, I can figure out what my x values are. So 7 pi over 6 plus 1 pi over 6 is 8 pi over 6. Or that simplifies to 4 pi over 3. That's where this first one comes from. The second one, if I add pi over 6, this one's kind of weird. I get 12 pi over 6, or it simplifies to 2 pi. So my 2 possible values for x here are, I'm going to write them down up top here. X equals 4 pi over 3 and 2 pi. There's one slight situation that happens here though. Whenever we're adding or subtracting a number inside the parentheses, we're shifting the function left or right on the graph. I don't really have a good visual representation of that today. But what we should see though is one of the answers is 2 pi. And whenever you have 2 pi as an answer, that means if I go exactly 2 pi units away, or exactly 1 time around the circle, I can get back to 0. And that could also be an answer. So the original answer was 11 pi over 6. And remember, Mr. Jolly last time talked about if we rotate exactly 2 pi units around the circle from 11 pi over 6, we're going to end up with a like 11 pi over 6 plus 12 pi over 6, we'd get 23 pi over 6. But that's outside the interval of 0 to 2 pi. But what happens is when we shift it up to 2 pi, by adding the pi over 6, we know exactly 2 pi units away is 0, which happens to be in our interval. So there happens to be 3 answers here, not just 2. Kind of a weird way to think about it. That's a tricky problem there. But that could happen from time to time whenever there's going to be like some type of shift. And by the shift, I mean there's going to be a number inside the parentheses. Like here, we see the x minus pi over 6. I'm going to box that answer. Got a lot of work shown here. But 0, 4 pi over 3, and 2 pi are the 3 possible answers. I'm going to go ahead and pause the video and erase the circle, and then we'll try another example. Okay, let's move on to example B now. Example B shows us this 2 sine squared of x minus sine of x equals 1. So the first thing Mr. Jolly talked about last time was we want to make sure we have, with trig values, we want to make sure we have the same trig functions across the equation. So we have a sine there, we have a sine there. That looks pretty good. Because it's a sine squared of x minus sine of x, what we're going to want to do first is we're going to want to treat it like a quadratic equation. So 2 sine squared of x minus sine of x minus 1 equals 0. So all we did first was we subtracted 1 from both sides. So that way we could get an equals 0. And Mr. Jolly talked about this last time specifically where he said, oh, you could think about this as like 2x squared minus x minus 1 equals 0. And then kind of factor it where you're like, oh, okay, one of these could be 2x minus 1 and the other could be x plus 1 equals 0. And we're turning that trinomial into 2 binomials. Well, the exact same thing is going to apply down here with the sines. One of them is going to become 2 sine of x minus 1. The other one's going to be x plus 1 equals 0. And then because we have the zero product property, we can say, okay, well, one of the equations will be 2 sine of x minus 1 equals 0. The other one's going to be, whoops, shouldn't be just x plus 1, should be sine of x plus 1. The other one's going to be sine of x plus 1 equals 0. And now we can go ahead and solve for our sine functions. This one's going to be sine of x equals 1/2. The other one's going to be sine of x equals negative 1. So if we look back up to our unit circle above, we're looking for the y values of positive 1/2. There's one at pi over 6. There's another one at 5 pi over 6. And then we're going to look for y values of negative 1. And there's one at 3 pi over 2. So those are our possible answers for this particular problem. There was pi over 6, 5 pi over 6, 3 pi over 2. And again, just to find those answers, I just kind of started at 0 and I worked my way around the circle and looked for all the 1/2 values. And then I went again around the circle and looked for the negative 1 values and found all of them. And that's how I arrive at my answers for this particular problem. Okay. All right, moving on to example C, we have cosine of 2x equals root 3 over 2. So this one's already solved for us. We just have this this 2x inside the parentheses that we're going to have to deal with kind of a little bit later. But for right now, we're just looking for when the x values equal positive root 3 over 2. Hey, there's one right there at pi over 6. Looking around the circle more, you see a negative root 3 over 2, so that's not quite it. Another negative root 3 over 2. Hey, there's a positive root 3 over 2 at 11 pi over 6. So that's how I can determine what my values are. So 2x equals pi over 6 and 11 pi over 6. But now what happens is that's what 2x equals, not what x equals. So I have to divide both sides by 2, and I'm going to get x equals pi over 12 and 11 pi over 12. All right, but if we remember at the very beginning we talked about, hey, this interval is 0 to 2 pi. So if I took all of these values and I divided them by 2, well, pi over 12, and the effect that this 2x has on the whole equation, that has to go back to like when we thought about the graphing part. The b value is 2. So I think about like, hey, this was b equals 2. So that means if I did the period was 2 pi over the b value, which is 2 pi over 2, the period of this function is just pi. So when x equals pi over 12 and 11 pi over 12, that's showing, if I look up at the circle, that's a period of pi, which is half the circle. But I need to go from 0 to 2 pi. So what I need to do then is I need to say, okay, I need to add pi to each of these values. So for example, I can say pi over 12 plus pi. Or pi is the same thing as 12 pi over 12, which makes a 13 pi over 12. That's going to be another value that falls inside the interval. If I did 11 pi over 12 plus 12 pi over 12, I get 23 pi over 12. And that also falls inside the interval. So technically, I could add two more values here. 13 pi over 12 and 23 pi over 12. So this one actually has 4 correct answers that fall in the interval from 0 to 2 pi. Alright, so whenever we have a value that's inside the parentheses, like on part example A, we saw this pi over x minus pi over 6, and that ended up shifting the function and it added a value. Example C, we see this cosine of 2x, and that added 2 more values just because of the value was, because the b value was 2, and it changed the period of the function. So we have to be careful with those types of problems. When we get to example D, now we're going to be dealing with the tangent function instead of a sine or cosine function. And example D looks very similar to B kind of, except we already have a 0 on the other side of the equation, which is nice. So what this one means, I can technically factor out a tangent right now. And I can say tangent of x times tangent of x plus 1 equals 0. And I can factor that tangent out of both equations, and if I were to distribute that back through, I'd get a tangent squared plus a tangent of x. But now I've got two separate equations. One of them is going to be tangent of x equals 0. Zero product property allows me to do this. The other one is tangent of x plus 1 equals 0. Now I have a tangent of x equals 0. Well, where's tangent going to fall if I'm looking way up here? If I'm looking at this very first point where I have pi over 6, remember the tangent was y divided by x, right? So it's going to be 1/2 divided by root 3 over 2. Okay, so that's where you'd find a tangent, hopefully of 0 somewhere on here. If I did 1/2 divided by root 3 over 2, that's the same thing as 1/2 times 2 over root 3, which is 1 over root 3, which simplifies to something like root 3 over 3. So that's not 0. If I look around, I want to look for y divided by x. Well, at pi over 2, I get 1 divided by 0. Well, that's undefined. At this one over here, I get 0 divided by 1. Hey, that's true. That's a 0. So pi is one of our possible answers. The other possible answer is actually going to be 2 pi. So for this side of the equation, when tangent of x equals 0, I could actually say not just 2 pi, but I could also say 0. So I could say 0, pi, and 2 pi. Those are the three possible answers for when tangent of x equals 0. The other problem is going to be when tangent of x equals -1. And when I'm going to get a -1, I can see at like pi over 4, for example, on the unit circle above, I have root 2 over 2 divided by root 2 over 2. Well, that's going to be a positive 1 for a tangent. And then in quadrant 2, that's going to be a -1. In quadrant 3, that's going to be a positive 1 at 5 pi over 4. And in quadrant 4, that's going to be a -1 at 7 pi over 4. So technically in these problems, x is going to be -1 at 3 pi over 4 and 7 pi over 4. So for this particular problem, I have 5 possible answers. And I always want to try and list my answers from smallest value to largest value. So that's what I'm doing here. Rewriting my 5 answers from smallest to largest. Right, and that's example 4. When I get to example 5, I have sine of x times cosine of x equals 0. This is already 2 problems being multiplied by each other here. So technically I can write this as, hey, sine of x equals 0, cosine of x equals 0. So when's the sine function going to equal 0? Well, it's going to equal 0 at the 0, pi, and 2 pi, just like the tangent function. When's cosine going to equal 0? That's going to be when x equals pi over 2 or 3 pi over 2. So for problem 5, we're going to list our 5 values. There's 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that's what problem 5 would look like. Alright, and last but certainly not least, we have problem 6 here. Highlighted in blue here for us. 4 sine of x cosine of x minus 3 cosine of x equals 0. So this is one that Mr. Jolly was talking about, where we have 2 different trig functions here, a sine and a cosine. Unfortunately, none of them are squared, so we can't use a Pythagorean identity to change anything out. But what we can see is, hey, I've got a cosine here and a cosine there, and it's all equals 0. So technically I could factor out a cosine of x and just write this as 4 sine of x minus 3 equals 0. So one of my solutions is going to be cosine of x equals 0, which we literally just did in part E. The other one's going to be 4 sine of x minus 3 equals 0. So when cosine of x equals 0, x equals pi over 2 and 3 pi over 2. 4 sine of x equals 0. Well, that's going to be sine of x equals 3/4. Well, if I'm looking at my unit circle above, there isn't any like y values of 3/4 anywhere on here. So it's not going to be an easy solution to find sine of x equals 3/4. The best way to think about this particular problem is if I were to sketch the graph real quick of sine of x, so y equals sine of x here, draw my 0, my minimum, my maximum, another 0, my minimum, and 0. Here's a quick sketch of it. It goes 0, pi over 2 is where the maximum is, 3 pi over 2, and 2 pi. We've sketched those before now. The maximum value here is 1, the minimum value is -1. Okay. So we saw that pi over 2 comma 1, that's one value there when x equals pi over 2, y equals 1. But what we want to look for is when x equals, or when y equals 3/4, I mean. So 3/4, because that's what we're looking for up here. When does sine of x equal 3/4? And that's going to happen right here somewhere and right here somewhere. So we're looking for these 2 x values. And unfortunately, the unit circle is not going to help us with this problem because they're not exact values. We would have to approximate them. And the best way to approximate those problems is to actually look them up on a graphing calculator. Or you can use Desmos to do it as well. And the way you'd want to use this on a calculator is you'd want to graph the equation y equals sine of x, and then you're going to graph a second equation y equals 3/4. And y equals 3/4 would draw a solid line across like this and say, hey, look, there's 2 intersections. And then when you look that up on the calculator, you would find your 2x values and say, hey, one of them is 0.848. We'll just round to the nearest 10,000th here. The other one's going to be 2.294, something like that. And that's how we'd find our final x values. We'd say, okay, well, there's going to be an x value at this weird point. We want it pi over 2, which is an exact value. There's going to be another one at 2.294 radians. And there's going to be a final one at 3 pi over 2 radians. All right. and that would explain our 4x values. Remember that 6.28 radians is the same exact thing as 2 pi. It's just 2 pi is the exact value. 6.28 would be the approximation. So that makes sense that the 3.14 would be the same as pi. So it makes sense that 0.848 and 2.294 all fall below that 3.14 value. All right, that explains everything for today. Good luck on the assignments. And as always, make sure you hit me up on my office hours if you have any questions.